All right, in example 16, it wants us to determine which equation will have a lower y-intercept. So again, we got to look for features of each equation that make it easy to get 1, so we only have to do a little bit more work. So if we look at this one, this is in standard form and this is in vertex form. Standard form is great for finding the y-intercept. It is the last value. If you're given ax squared plus bx plus c, then c is the y-intercept. Okay, so that means that in this case, the y-intercept here is 5. Okay, so we know 5 will be higher if this is lower than 1, or lower than 5. So let's figure this one out. Okay, so this one we got to transform into standard form, which means we expand x minus 1 squared. So x minus 1 squared means x minus 1 times x minus 1. We square that. We get x times x, which is x squared. Then we get x times negative 1, which is negative 1x. Then we get negative 1 times x, which is negative 1x. And then we see negative 1 times negative 1, and we get positive 1. So we get x squared minus 2x plus 1. But that is still in negative 2 form. So we still have to multiply by negative 2 and then add 1. So let's go ahead and distribute. So we get negative 2x squared plus 4x minus 2 plus 1. Okay, combine like terms and we get negative 1. So it's negative 2x squared plus 4x minus 1. So there's my y-intercept. So the y-intercept here is negative 1. So which one has a lower y-intercept? The lower y-intercept belongs to g of x. So we will say that the function g of x, function g of x's y-intercept of negative 1 is lower, or we could say lesser than, the function f of x's y-intercept.